Hi everyone, Onboard here. Today we are running Windows 98 on an AM3 Plus setup powered by none other than the AMD FX-8350, the world's first consumer 8-core CPU, or at least that's what AMD advertised. In reality, it uses a Bulldozer architecture where every two cores share a single FPU and other resources, meaning it functioned more like a quad core with extra threads than rather a 8 true core chip. But despite that, still remained a popular choice and a bit controversial. Now, I'll admit I kind of overlooked the AM3 Plus platform back in the day and also in my recent videos, but here's the thing. AM3 Plus boards are actually more retro-friendly than Intel's Sandy Bridge and Ivy Bridge platforms, which were the competition back then. Take this high-end ASRock 990FX motherboard, for example. It has both floppy and ID connectors, while also packing modern features like SATA 3, USB 3.1, and of course 8-core CPU support. Well, I don't have this ASRock board, but a more budget-friendly 760G model released around the same time. Well, this board includes floppy and ID connectors as well and is officially compatible with every OS from Windows XP up to Windows 10. And as you are about to see, it's also a perfect match for Windows 98. All right, so let's move on. I won't be doing a fresh install this time. That would just make this the fourth or fifth video showing the same process. Instead, I'll be using the exact same SSD from my previous Windows 98 on 14th gen configuration video. Now, Windows 98 should automatically detect motherboard resources and the PCI devices again. So we'll be good to go, but a lot of clicking is required. As you can see, everything went smoothly, no errors, and every device was recognized as expected, including the AACI ports. This means we should get the most out of our SATA SSD at the next reboot. Even better, Windows 98 detected the USB 1.1 controllers, which is a great sign. I'm not sure if this was a glitch or not, but there were about 5 OHCI controllers, when usually there are only 2. Either way, USB is working fine. We'll get into that later. For now, let's take a closer look at our configuration and run a 3D Mark 2001 test. But before that, I ran the SiSoft Sandra 99 standard CPU benchmark, and our FX-8350 scored around 11K points while running at 4 GHz. Then I came across a screenshot, literally a shot of the screen of an Ivy Bridge i7-3770 performing the same test, and it was about 32% faster, scoring about 15K. Meanwhile, an i5 14th gen CPU running at 3.5 GHz was roughly 80% faster. As for the 3D Mark 2001 test, everything ran smoothly while using an NVIDIA 7900GS with Rudolph Lau's patches. However, this core is heavily dependent on CPU performance. When matched with a modern CPU, this 7900GS can easily go over 50K points, but with the FX CPU, it ended up with just 35K. At this point, as I was preparing to take the perfect screenshot, I realized I was running with just 512 megabytes of RAM. Not that more RAM would change anything on these previous benchmarks. Anyway, this configuration should handle more, so I deleted the max fizz page from the system ini file, and since patchmem was already installed, now we have 3.3 gigabytes, almost the same as on my Ryzen 9 configuration. But there is a problem. Some those games won't start with this much RAM, so we have to limit the available RAM if we want to play something like NQ Rally, for example. This sound, by the way, is handled by PCI Creative Sound Blaster 128, which works wonderfully with those games as long as we use WDM drivers. But what if I told you we can get sound through the onboard HD audio codec using a 16-bit Windows 3.1 driver. Sounds crazy, right? Well, this is actually the first time I got this driver to work. I had tried it a couple of times before on newer motherboards without any success, but maybe I just didn't try hard enough. Some tinkering is usually necessary to get it running. This time, though, that wasn't the case. I got sound just by installing it. The only difference, I used a custom INF file made for Windows 98. And honestly, I'm surprised by how clean it sounds. Now let's not forget, this driver was designed for Windows 3.1, so it has its limitations. It won't work with those games since it's not a WDM driver, and being a 16-bit driver, it could cause some instability. But so far, I've played a few games, Windows games, and it ran just fine. And if there is no other option, like if you're running Windows 98 on a laptop, this is definitely the best driver out there, if it works. Anyway, a big thanks to Wattler's World for making this possible. Now let's set up our USB, one of the best retro features on this motherboard alongside the floppy connector. Now, Windows 98 has already detected the USB 1.1 controllers using its built-in default drivers. This typically means we can also use a generic driver for the USB 2 controller. Not too long ago, I tested an NEC PCIe to USB 2 adapter, and I used the same generic drivers here. And yes, they worked perfectly. However, there is a small catch. Neither this driver nor Windows 98 includes a USB mass storage driver. Back in the day, that driver usually came bundled with our USB flash drive. We can use such drivers, of course, but there is a better option called NUSB. This is an unofficial patch which makes Windows 98 much more USB friendly by using some files from Windows Millennium and even Windows 2K. Let's say that now our Windows 98 is not in a pure state anymore, but we do get a working USB mass storage driver and better transfer speeds overall. To get NUSB working, we should manually uninstall anything related to USB in the device manager, including the USB 1.1 controllers. And at the next restart, everything should be detected and properly installed using the newer drivers. And that's exactly how it went on this configuration. Once we are done with NUSB, the USB mass storage should work flawlessly, but there are a few things to watch out for. If the USB legacy option is enabled in the BIOS and we boot the PC with a USB stick plugged in, the BIOS might mount it as a fixed drive. This can cause issues since Windows will see our stick as both a USB drive and a fixed drive at the same time. Other than that, USB drives work just like they do on newer versions of Windows, and the transfer speeds are pretty good too. Now it's time to tackle the SMBus, that one recognized device in the control panel that drives people crazy. I mean, there are over 1.4 million Google results on this topic for a reason. Well, technically, Windows doesn't need a dedicated driver for the SMBus. In most cases, installing the chipset driver is enough to register it properly with the system. So I went with an SMBus driver from Windows XP, and it worked like a charm. Now that I have sorted out the SMBus, I had to check the floppy drive functionality. Not that these two are related in any way. And of course, if it's enabled in the BIOS, the floppy drive works, especially if you remember to insert a disk first. Well, one thing that didn't work was the Gigabit Ethernet card with a Realtek 8111 chip. The chip on this board is an F revision, while Windows 98 only supports up to revision D. Normally, that wouldn't be a big deal, but later Gigabit Realtek chips just can't be initialized in Windows 98 using 32-bit drivers. They do work with an NDIS2 driver, which is a 16-bit DOS based driver, but using such driver can make this system really unstable. And speaking of instability, this was probably the least stable Windows 98 setup I have used in a while. Most issues were GPU related, but there is also the CPU. which is a 125 watts model, while this board officially supports only up to 95 watts. But it runs in single core mode, so in theory it shouldn't be a big issue, but still something to keep in mind. Also, I didn't disable any power related features that can cause problems. But let's look at the bright side. The soft shutdown does work. The downside? Well, it only works when it feels like. But this is a known issue of Windows 98. That's all for now. Thanks for watching and for all your support.